In this video, we'll be applying the concept of concave up and concave down to determine what this graph is supposed to look like. So the first thing we're going to do, recall, is that when I want to go ahead and find concavity, I have to take the first derivative. But note, the first derivative does not give me concavity. The first derivative provides me with the increasing and decreasing of the original function. If I take the second derivative, that's going to provide me with the information as to where the original function is concave up or concave down. So, keep in mind, when I go ahead and take the second derivative, I need to find its critical points. The critical points, recall, are where the derivative, or in this case the second derivative, either does not exist or the second derivative equals to 0. So I'm going to go ahead and find the critical points for this function. You'll note that this is a linear function and therefore has no locations where the second derivative does not exist. Again, I note that even though we don't need to. I note that because if we forget to check that, we're going to have some missing values. So the next thing I'm going to do is I'm going to go ahead and set that derivative equal to 0, giving me x equals 0. So this is my only critical point for this graph, which means that I'm going to go ahead and draw a number line with 0 in the center. I'm going to go from negative infinity to 0, and from 0 to infinity. Those are my potential answer ranges. I'm going to go ahead and have some test values in here, making sure that, again, I draw this nice little line separating all my information. In this test interval, I'm going to select -1. In this one, I'm going to select 1. Again, I just need a value between negative infinity and 0, and between 0 and infinity. And -1 and +1 seem like the easiest values to choose from. Next, I'm going to go ahead and identify what is the second derivative function doing. Again, I don't want to know what the derivative function is doing. I want to know what the second derivative is doing because I want to look at concavity. So, when I take the second derivative and I plug -1 into that function, right there, 6x, I'm going to get a -6, which is actually a negative value. When I plug in 1 to that, I'm going to actually end up a positive value. Now keep in mind, if the second derivative is negative, the original function is concave down. We can abbreviate that as CCD, again, concave down. If I get a positive second derivative, then my original function is concave up. And again, we can abbreviate that, CCU. Hence, in this particular problem, I can say that my original function is concave up on the interval from 0 to infinity, and is concave down, abbreviate that one, negative infinity to 0.